For our second talk, we are moving into the world of web application security with Michael Berkowski from the libraries. Take it away, Michael. Thank you very much.
Good morning. How's my level? Is my microphone level okay? Can you hear me? I'm ringing a little bit, so I may actually bring it down just a tad. Okay. Good morning. My name is Michael Berkowski. I'm a software developer with the University Libraries, and I hope I end up deserving of the legitimacy that this big auditorium adds to this morning. So I want to talk to you a little bit today about testing the security of your web applications, both ones that you have built in-house over the years, maybe some that you have been using since the early 2000s, that may have been built by a junior developer in 2002, and the ones that you actually have licensed from a vendor, because we have, over the years, discovered a lot of issues with both classes of those. So when I say gently testing the security of your websites, I really mean it. I'm talking about things that a developer sitting at a desk can do to prod and poke a site a little bit without, I'm going to bring this down because I don't want to, that's better, without invoking a really aggressive automated tool like Qualys, which is going to just beat on your website and destroy your database and take 4 hours to run. That's not what I want to focus on today. So I want to tell you a story about what things can fail in your vended applications and your home-built applications and cause exposure of student staff data, malware, loss of data, theft. This is a true story. So last year, right around this time, March, April last year, May, the libraries were evaluating a web application from a vendor. It's a very well-known application that is in use by all sorts of libraries, academic libraries, public libraries, academics of all sizes, from small colleges up to huge Big Ten-sized universities. And it had a CSV file import feature that we thought was going to be pretty helpful to use. We were planning on migrating from an application we had built in-house, and the CSV import would do the job for us, so we hoped. So we tried importing some of our data. Now, the application that we had been working from in-house was built, it's one of these kind of older applications. It was built in the early 2000s. It supported a small amount of inline HTML formatting in some user-submitted data. So importing into this vended application, on the very first attempt, that little bit of HTML formatting showed up on the screen after we sucked in our records. And I thought, like, wow, cool, this supports HTML. That's exactly what we need. I didn't even really plan on that or think about that or even realize that the data I was exporting out of our old system had the bits of HTML in it, but so it did. So we moved on to importing a larger set, but this time it broke right away. We only got a half-rendered screen, and this like raised eyebrows with me immediately. So I opened up Browser Inspector and looked to see what made it down to the browser from this web application server. And everything was there. Everything was available in the page source, but not rendered on screen. So this now raised my eyebrows even higher. And I start thinking, okay, well, maybe there's some minor like HTML escaping bug in here somewhere that we could get in touch with the vendor about. But the bigger possibility was that maybe it really wasn't supposed to support HTML at all. And if it wasn't, then we might be in a situation where it was vulnerable to a type of web application attack called cross-site scripting, or XSS, which we'll go into a little bit more detail on later. So we ran a test. We explicitly, deliberately on purpose, poisoned our CSV file with what is a classic, that's the button? That's the button. A classic way of injecting some JavaScript into a web page to make it do something that it wasn't supposed to do. And it worked. And we were able to make a little pop-up message appear on the screen. So, okay, thinking, now there's a vulnerability here, but it doesn't seem like a vulnerability that is maybe so terrible right from the beginning, because in order to, the CSV import was for administrative users of this application. So it would have to depend on the administrative user being given a specially maliciously crafted CSV file and then tricked into uploading it. And this is possible, but it's kind of far-fetched. It's not like, it's not something that could easily happen every day. So we start thinking, well, okay, what could go wrong with this in this scenario as we understand it right now? That injected script could do things that JavaScript can do in a browser. It could read the administrative user's session cookie. It could manipulate stuff that's rendered on screen in the user interface, like fake clicks around and things, submit forms, type in fields. Or it could actually change what the administrator saw on the screen. And those are all really bad things. But again, remember, this is not an easy vulnerability to exploit. It's not one that seemed like it could be exploited by just like clicking a malicious link. So it's not super duper serious, unless that wasn't the only thing wrong with this application. So at this point, we got to digging a little bit deeper. First of all, I got permission to start digging a little bit deeper from my superiors. The course of action at this point is to just use the application how it was intended. Open up a browser console, open up a JavaScript console, a browser inspector, network inspector, and watch what happens while using this application to get a sense for how its forms transmitted data to and from the web server that it lived on, and just watch what its network activity looked like in order to figure out what could we do with this thing. So because this was a regular web application with regular old forms, we found using the browser inspector, we could do things like change values in the forms and have that result in users not even affiliated with our institution showing up in lists. So eyebrows are like going much higher now. And so it didn't end here either, unfortunately. We found that by inspecting the forms we were submitting, they didn't appear to include anything any data with them that was not the data that we had explicitly typed into the form. So I just said that in a very confusing way, and I apologize. The forms didn't transmit back to the server any kind of unique identifiers or tokens that validated the action being sent to the server had permission by the form. And so that meant there was raised some suspicions that this could have been vulnerable to a type of attack called cross-site request forgery, or CSRF, which we'll get into a little bit more detail on later. So the biggest worry now that came into our heads was that this application used by hundreds of American universities, probably thousands of American universities and all universities worldwide and public libraries, could be vulnerable to a phishing attack, a targeted phishing attack, whereby administrative users could be tricked into doing things that they did not intend to do. So we started theorizing, what could we do here? A theoretic attack in this might be one in which we sent out a survey to the users, known users of this application, which once again, there are many. Could we get an administrative user at another institution to click on a link that caused something to change in their instance of this application? Could we do something like make a user unknowingly create a new item, change stuff they didn't have permission to change, like a regular user account without administrative rights? Could they have been made to perform administrative actions? And could we cause changes to data just by clicking a link from completely outside of the application? And yes, was the answer to all of these things. At this point, I want to show you, I want to spend a few minutes showing you how we went about digging into a few of these issues. But before we do, nothing that I'm going to mention today do I have permission to give you permission to do, okay? this is anything you would do in this realm. You're undertaking at your own risk. These methods, like I was saying, this is for something that a developer could do sitting at a desk to sort of poke and prod a web application, preferably one in a test environment, not a production one. And these things aren't meant to deviate too far from how a web application is intended to be used. But your vendor contracts, your managers, and UIS here at the university may completely disagree with this. And so I'm not giving you permission to do these things. You need to get your own permission. Okay, so first let's look at cross-site scripting, or XSS. HTML, the markup language that structures our page and gets delivered from the server to your web browser, it doesn't do anything itself. It's just a bunch of text, and your browser knows how to arrange that text into something more or less how the designer of that page intended for it to look. It doesn't move stuff around. It can't really do much at all. But the JavaScript that comes along with it can. It is the programming language that makes your browser do stuff. If a button flashes or a picture swoops in from the side, it's JavaScript that's doing those things. Your web browser is very careful about what types of scripts it's willing to execute. It will not accept a script that just comes from anywhere. Your browser won't execute a script unless it comes from the same domain as the page you're viewing that's currently in the browser window. But the problem is, and what causes cross-site scripting attacks, is that the browser can't determine what's good and valuable and allowed code from what is disallowed code if it comes from the same place as the page you're viewing. So, in order to execute a cross-site scripting attack, you need to place JavaScript into the page that wasn't supposed to be there. And so let's take a quick look at how this can happen, how this works. HTML has special characters that help organize things on the page. Angled brackets, greater than, less than signs, surround tags. You can't just stick one of those, a greater than or less than sign into an HTML document and have things work out right all the time. The browser is going to think that you're trying to make part of an HTML tag and probably break everything that comes after it. So in order to get around that, if you really explicitly want to put a greater than, less than in your page, you need to escape those using these sort of entity encodings like that. In order to get it to just show as regular old text. So if you have an application that allows users to submit values in forms, and they were to put something like this that actually includes some HTML into your form submission, your browser, if this isn't handled the way you want it to be handled in the application, your browser might, oops, sorry, no, wrong button. Your browser might show it as rendered HTML, like a big title got inserted inside that string, instead of the plain text version of that. So the same is true for the script tag, which delivers JavaScript into your web pages. If an application does not look for this, does not watch out for this, and change those bracket values of greater than, less than signs into their encoded versions, the browser is not going to know the difference. And it's going to happily execute any JavaScript code that gets placed in there. So in this case, there's a little bit of text here, but also a script that does some nefarious thing like issue a pop-up ad into the screen. If it properly escaped, it would be sent to the browser like this and then not executed. So what could go wrong if we do this? A whole lot of things can go wrong. So JavaScript has access to do pretty much everything that the user sitting in front of the browser window can do. It's able to read the session cookies that the user has stored in their browser at that time, which means it can maybe steal some details and maybe use those details for other related sites or other actions on the site. Here's an example of that, actually. This isn't a great example. It looks like it's scrolled off a little bit. This is a little example of a script that could steal your cookie and send it off to a third-party site disguised as basically an image file embedded in this site. So these are the kinds of things that could happen. User's administrative cookie could be taken. It might have valuable personal details in it, possibly, just shipped off to another site completely unbeknownst to the person looking at the screen. So let's watch this kind of thing in action. I have with me here a couple of real live vulnerable web applications. This one is vulnerable to cross-site scripting. It's a blog. It's a blog with a real actual comment section that really works. Whoops, wrong one. What I wanted was, I'm going to try to make it a little bit bigger. Okay, so here's a comment section. I can put in a comment and submit it. Post my comment, and here it is. It shows up right away. I also happen to have packaged in here a couple of examples of what cross-site scripting could do to this page if it was not properly filtered. We could change the content of the post. So I'll leave the name blank, but I just dumped in a perfectly innocuous comment here, plus a bunch of other JavaScript code, and immediately on reloading the page, I've just hijacked the blog post. Now, I didn't change it on the server. If we were to look at the page source, the whole original blog post would still be there. But essentially, I took this and put a big, obvious, like, advertising message up there. A lot more nefarious things could be done if you could think in that direction. Maybe I could add a little sentence or replace the content, replace one word in each one with a political statement or something that users reading this site won't necessarily know that it was nefariously injected. Administrators of the site won't necessarily know either until someone tells them, because it's not going to show up on their server. This is only what the browser shows. So this is kind of nasty. Let's reset that. I could do something like, in as much as I could put in a blog post, I could or put in an ad there. I could put like a really bad banner ad in. Let's get rid of that one. Or I could just flat out steal users from this site. So here, once again, is my perfectly innocuous comment, and I'll post it, and everybody else who comes to this site is immediately going to be redirected away. If this was handled properly, let me reset again. Let's go back and put up the hideous banner ad again and post it. And scroll down here. If I switch my application here into what I have built into it as its safe mode to properly handle these scripts, you still see that down on the screen? Yeah, it's kind of small. But so at this point now, instead of executing this script, the browser has been instructed to encode it and display the original text of it. So this is the way that this attack is mitigated. So how can you test for this? Well, first of all, where do you need to look? You need to look in any place where users are able to submit text and have that text appear back on the screen in any other context at all. Just like a really obvious example, like a blog comment. But this could be and really anything in your web applications where users are entering titles or descriptions of things and saving them for later where they're going to be shown on the screen. All of those areas could be vulnerable to this type of attack. And so you can test them yourself by just sticking in a little script that tries to show a little alert pop-up on the screen. And you'll know right away if it works, because you'll get a little pop-up message. And to prevent it, you need to just make sure that every user text submission that gets displayed on the screen later has been pre-treated for shipping down to the browser. And the ways that this is done vary across programming languages and across web application frameworks. But the thing is, most web application frameworks nowadays do this automatically. This isn't something that you should have to worry about too much, but it is something you need to worry about if you're dealing with an old application that was built, say, 12, 15 years ago without the help of a modern framework. Here's a couple of language examples. I'm not going to leave this up too long. If you're using a particular language, all you need to do is search for HTML escaping or XSS prevention in that language, and you'll find out some good and probably very easy mitigation techniques. The OWASP, the Open Web Application Security Project, I think is what that acronym is for, and just the plain old Wikipedia page on cross-site scripting are very, very good resources. So the next one I want to move on to is the issue of the cross-site request forgery. Remember, when we only thought that an administrative user would have to ship a poison CSV into our application, it didn't seem that bad. But once we discovered the possibility of the cross-site request forgery vulnerability, things got a lot more dangerous. So this is an attack that causes a user to do a thing they are permitted to do. They have the privileges to do, but make them do it inadvertently. They do it without intending to. So I click a link. I'm the administrative user of this application. I click a link, and the act of just clicking that link in an email or something causes a new user to be added to my application who has administrative privileges. That's the type of thing that can be accomplished with cross-site request forgery. So the problem here is that the HTTP protocol that transmits text between the browser and the server, it's stateless. The server generally has no idea where a web request it's getting came from and has no idea what came before that. So it doesn't necessarily know that a form submission that was posted to the server came from the act of an administrative user clicking on a submit button within that application. As long as the person using that application, as long as the person making the request knows how to make it appear that it came from the right place, the server might just accept it and execute it. So typically this is exploited by hijacking a user's browser session. It is exploited based on the knowledge that an administrative user of an application might be logged into that thing almost all day. If you work on a web application that is essential to your job, say you're entering financial records all day long, probably there's a good chance you are logged into it all the time. And if somebody can assume that you will be logged into it, then they can try to get you to do a thing in that application you did not intend to. So an application can be vulnerable to this if it does not accept along with a form submission, along with data posted up to the server, some kind of random or hard to guess value that the user did not explicitly type in. That's known as a CSRF token or a security token. So how can you check for these? Well, open up your browser inspector. Go to the network tab and set it to preserve logs and just start watching what happens while you use the application. Watch the post and get requests come in and out of the application. Specifically look for the posts. There's an example there of what that would look like in my network inspector. The post is the act of me clicking on the submit button inside my app. And so here's one that I might find in that post is vulnerable to cross-site request forgery. It has a username and a name and some admin information, but no other like hard to guess, long, random looking value. Here's the same one with that type of security token in there. That is not vulnerable to cross-site request forgery. So you can test this by copying that post request and executing it with a command line tool called curl. So this is a curl command. It's a big, ugly kind of command. But all this does is fake a browser action sent up to your server. And if this works without that token in there, then and the thing you tried to do shows up in your application, the change you tried to make shows up in your application, then this is possibly vulnerable to cross-site request forgery. So what could happen here? Well, let's look again. I've got another vulnerable web application. So here's a web application. It has a login page. I'm going to log into it as the administrator. And it shows, here's some things related to my session. This is my session cookie. This is the thing that identifies me as an administrator in the system, my browser. And it gives me a little interface to add users. So let's add myself as a new user here. And I will be an administrator, and I'll save it. And so there I am. Here's what I posted. Here's what my action just sent up. My username, my real name, the fact that I'm an admin, and then the save button. This is not safe from request forgery right now. If I set it into safe mode and do the same thing again, let's not be an admin this time, and say this one. This time it generated this token. And my server, the application server has checked that the value of this token matches the value that it expects to receive. I didn't type that, but the browser knew to send it based on how the form was structured. So let's log back in, because again, this depends on being logged in. So here's our survey. This is a completely different, legitimately different website. This lives on a different web server than this one does. So from the browser's perspective, they are not the same place. They should be completely unrelated. I sent a survey, and I asked, did you like our software? Well, no. And does it work pretty well? Yeah, it works pretty well. I guess I must have named these the same. These should be different. Doesn't matter. So on submitting this survey, I think I'm just, giving them a data point. What I really just did was add this, add evil user into their admin interface when they didn't intend to do that. And for added measure, you can see I stuck a cross-site scripting attack in here. So if this user gets clicked, some scripted action can now take place. So this was the main pain point that we found in our vended application, where things really could go off the rails. For time, I'm not going to show you the other version of that, the safe mode version where the user would be rejected. So again, most frameworks handle this for you. There are typically one thing you maybe need to add to a web application to globally prevent this, which is handy. And I think also for time, I'm going to just breeze through the things to address. You need to create that token. Your browser needs to have the token to send back to the server, and the server needs to save it, something like a session value or a database. And when you get it back, you need to check that the server needs to check that the one it got from the browser matches the one it expected. Again, go to the OWASP page for cross-site request forgery resources. And let's just quickly move on to how to deal with disclosing these things to your vendors and to your superiors in your department. Before you tell anybody outside of your own unit, tell your superiors what you found. And don't dive right into technical details, but explain what the potential is for damage. Explain the scenario where things could actually go wrong, and how users of your application could be impacted by this. Suggest then to your superiors that this issue be first brought to University Information Security, who will probably have additional guidance for you immediately. As far as informing the vendor, this is sensitive, but it's necessary. I mean, we kind of have an ethical responsibility to make sure that the vendors of our software know about the vulnerabilities in them, and we have some responsibility to let them know of that before we go and tell our peer institutions who use the same applications. So if you have a customer representative who you deal with, don't dump technical details on them either, but explain to them that you have found a security issue that you're concerned about, and you want to know what is the correct channel to report it in their organization. They may have a security team of their own, and if they do, that's a great thing. Just the fact that they have people who are already equipped to handle a security issue probably means that everything's going to work out really well for you in this. Be really detailed. Tell them how you found what you found, with detailed steps for reproduction, just like we would do as developers reporting a bug. And really, be thankful to them for taking the time to take your report seriously. If you have to deal with a vendor contact who doesn't seem that interested, or just says, let me know, tell me what it is, and I'll figure out internally who to send it to. Again, don't focus at all on the technical details. Give them concrete examples of what the effect of this is. Like, we were able to cause a user to change something they were not supposed to be able to change. We will tell you more when you ask for more. Or we will be able to make a banner ad pop up in the application. That shouldn't have been possible, we don't think. We'll tell you more when you ask us how we did it. What could go wrong with this? this process, well, they just may not listen, or they may not understand. And so it's really on you to be clear about it. And again, University Information Security probably will have good guidance as to how to go about explaining these things to the vendor. Should you tell others who use this application? Again, don't do it without permission. In our case, we were advised not to do that, right? Not to tell other peer institutions about this, despite the fact that we are aware of hundreds of them at least. And if they don't take it seriously, you might consider, I just said don't do this, but if they don't take it seriously, you might consider getting somebody else you can in confidence at another institution or some other customer of this application, and pairing with them to just check your notes together, make sure that they can verify that what you did or what you found is really a danger, and then bring it together up to the vendor. But still, don't distribute it widely. So our story ends with this application. With the vendor eventually coming around to understanding what we were trying to convey and working with us over the course of a couple of months to solve those issues. I'll finish up here now, and I want to acknowledge University Information Security, Natasha, and Derek, who worked with us on several meetings in order to figure out just what we were going to do with this information we were discovering in our vended application. And also thank my own superiors at the libraries for basically allowing me to go through this process, do something that maybe seemed a little bit dangerous or reckless at the time, but ultimately had a positive outcome for customers of this application. That's me. I'm actually meant to, if you have questions, because I know I'm out of time, you can send either privately or publicly, put questions on the Slack channel. Do we have time for any in person?
I think we're running pretty late, so we're going to do questions over pizza.
Yeah. So I will be around either while we eat or dump questions in the Slack channel. So thank you for listening.
Thanks.